Good afternoon. Welcome you all to the second High Performance Architecture webinar series. My name is Lan Ding, Associate Professor at UNSW School of Built Environment and the convener of the High Performance Architecture Research Cluster. Before we begin, I would like to show my respect and acknowledge the Bedigo people who are the traditional custodians of the land on which this meeting takes place, and to elders past and present. This is the second High Performance Architecture webinar this year. The speaker is Scientia Professor Dale Prasad, CEO of the former CRC for Low Carbon Living. This year, Professor Dale has co-led two successful bids. The first is the New South Wales Decarbonization Innovation Hub, 30 million in funding. The second is the Australian Trailblazer for Recycling and Clean Energy, 230 million in funding. Professor Dale will serve as the CEO of both. In today's webinar, Professor Dale will present Race to Net Zero Carbon Buildings 2030. If you have any questions during Professor Dale's talk, could you please put in chat, and Professor Dale will answer your questions as many as possible at the end of his talk. Also, just a note, this talk will be recorded. We would appreciate if you switch off your microphone and video during Professor Dale's talk if you do not wish to be seen in the recording. Professor Dale, over to you.
Thank you very much, Len. If you unshare and I can share my screen. You have to allow me to share, I think.
Yes.
Okay. Can you see my screen?
Yeah.
The whole thing?
Yeah.
Yeah. Okay. Thank you. Thank you very much. Hello to everybody. We here at UNSW have been involved in buildings-related research, sustainability, and a broad range of things for many years now. Our previous groups called SAULAC, and then Center for Sustainable Built Environments, and then afterwards the Low Carbon Living CRC have produced lots of knowledge translation and data that has helped the industry in the past. Over the period, having been observing the changes, we have seen the importance of various sustainability measures evolve. Clearly now we are very much driven by the race to net zero carbon buildings, and we are hoping for a target time of 2030, and I will look at the case for it and how we navigate that. But more broadly, let me see if I can move the screen around. Can you see the change screen? Okay, good. So more broadly, I mean, we all familiar with the Sustainable Development Goals, and there are many of these. At the time of design and engineering, we talk about how we can effectively contribute to as many of these as possible through good design, good operation, good disposal of buildings, including the health, well-being of people inside them, considering the issues of affordability and equities or inequities that prevail. So a lot of these are in our thinking, and the reason for saying this is that we are mindful of these, but my talk will focus much more on carbon more generally. There are many cases now that we see of front end driving high performance from a number of perspectives. We just picked on one example here that I had access to and looked at various factors like regenerative design, massive on-site generation, even on-site food production, upcycled building materials, and water and waste issues, and these are coming online, and projects like this from Fraser's property are commercial ventures, and as you can see, that you can deliver good buildings and they satisfy living building challenge type requirements at the same time, amongst other requirements. So it can be done. We are doing it. The idea is how effectively can we learn from some of these, how we can set a better benchmark, pathways and targets so that we can drive more effectively towards all buildings trying to do the same thing. I mentioned carbon is the focus of my talk. So the case for carbon, net zero carbon, is very clear. Global surface temperature increase as a function of emissions here shows on the vertical axis the degrees historical global warming, how it's evolved, how the linear relationship between the cumulative emissions and the temperature increase is quite clear. This is from the latest IPCC report. And not only that the averages are clearly moving in that direction, but the difference between the worst case scenario and the best case scenario according to these projections. In the worst case scenario, we will by 2050, which is a date being flagged a lot, we're going to exceed 2.5 degrees C quite clearly. And under the best case scenarios, we would be under 2 degrees C, but that in itself is not the best result because there are more optimistic scenarios we can aim for. In Australia, the State of Climate report here shows also that the sea surface temperature and Australian surface air temperature both have from 100 years ago been on the increase quite steadily. And the science is clear, in other words, that these are occurring over a long period of time, and that we often do not at a community, at a people level, understand as well things like emissions, because they are invisible gases. The impact they have is out there, and some people question how you can link it effectively to what's going on. But when you look at the frequency of events over time, extreme heat events in this case, it's very clear that with all those changes in temperature, you can correlate the increase in frequency of these peak events, and not only how many of these, but how bad they are in terms of extreme events. So these things are all happening, and we have to be mindful very much that we are causing it through human action. When you look at the trends of warming, some years ago, going back all the way to 1910 again, when data started being collected in Australia, the average annual temperature was much lower, this gray zone here. But over time, the observed 20-year running average has been steadily increasing. And when you talk about 1.5 degrees C, as I mentioned earlier, by 2019, we have already reached the effective 1.5 degrees C global warming compared to the pre-industrial levels. So if we are already there, according to our Australian data, that probably corresponds well with the frequency of events and other factors that we observe more clearly. So we need to be very much mindful that this is beyond doubt in terms of science. It's a matter of how, under the best scenario, we can navigate these. And buildings and built environment are a clear opportunity, and hence my talk about buildings today. But at urban scale in Australia, close to 80% of people dwell in cities, urban centers. They are clearly hotspots, and we observe differences, temperatures now reaching in excess of 40 degrees C in many places, particularly in Sydney here where we live. Western Sydney, Eastern Sydney, differences are talked about a lot. Estimates suggest that cities are responsible for about 75% of emissions. And within these numbers sit transport and buildings as well, which are the larger of the contributors inside of that. So cities as a whole, but buildings in particular, are our concern as architects and engineers. We are looking at how best we can address some of these numbers that we observe. The Global Alliance for Building and Construction, which is part of UNEP, United Nations Environment Program, in their latest report show that building industry consumes about 36% of total energy, and 37% of total emissions are attributable to them. About 10% of the total is the construction side, the manufacturing, the embodied carbon, in other words, and the rest are about operational carbon at the moment. So these numbers are global numbers, global averages, and per country, these numbers are slightly different each time. So for country details, you can refer to your own numbers. But the point being that it's in that scale, 37, some countries go up to 40% or so of the total emissions being related to buildings. And it is, either way, very significant. A report recently by Green Building Council and ThinkStep showed carbon emissions from building stock 2019 and 2050 projected. 2019, 137 megatons of CO2 equivalent, largely operational energy. Because of the large numbers here, the relative embodied carbon is smaller. When we look at the projections on a business as usual, we are able to bring down the total from by about in the order of 79% through improvements that we will talk about and are being talked about by leading groups like the Green Building Council in Australia, the neighbors, and so forth. But the relative proportion of embodied to operational changes dramatically, because a lot is being and will be done in the future on the operational side. But embodied, the case for dealing with embodied is very strong. So we need to look at what we call whole of building issues, and I'll come to that in a minute as well. There are many good stories to point towards. Globally, again, emission and intensity has changed. It's gone down from 2015 to 2020. Energy intensity has improved, but at the same time, gross floor area is improving. The number of people, the population's increasing. But on the positive side, the number of countries with building energy codes is increasing. And investment in this whole area of carbon and renewable energy and so forth is increasing a lot. So you can see there is increasing commitment and improvement, in which case we are headed in the right direction, but we need to be doing a lot more. In 2020 baselines of CO2 emissions, when you look at from 2020 to 2030, business as usual would be about 29% increase. This is on a global basis by GABC. But in actual sense, because of the measures being brought into place, all the levers, improving tools, building codes, etc., we're looking at in the order of 51% improvements. So we would be better in 2030 compared to 2020, for example. And from that 2030, if you look at the increases in terms of business as usual around then, it would be significantly higher. But the measures that will evolve for the 2050 range in terms of both the what's happening at the grid level and what would happen at the building site level, we believe that this is a good indication from a 97% improvement by 2050, which is very close to the numbers that are being talked about in terms of emissions reductions. So we should be looking at a whole of building and whole of life way of thinking about these. Whole of building that includes embodied carbon and operational carbon, both, but across the stages from product stage, construction stage, use, end of life, and beyond life. When we start considering this entire timeline of building life, we can start making significant impacts in terms of reductions in carbon and to deliver on the 2030, 2040, and 2050 goals that we are beginning to have. Focus now, as I mentioned, through those numbers is getting back on embodied carbon because it was the less understood, perhaps, but less considered element of low carbon design. Many people now suggest that build nothing, of course, is one of the best options. Exploring alternatives, building less, maximize the use of existing assets. I remember being 10 years ago, being part of a project with the Tokyo University on how to redeploy buildings. It was urgent for them because around that time, their population stopped growing in a net growth sense. And as a result, they were having buildings that were unoccupied. And we were looking at building deployment as a serious strategy when the population is not increasing. And they have gone a long way in countries like Japan where they have considered these. But building clever is clearly something we should be looking at, and building efficiently and being mindful of whole of life issues. There are tools available now, but there are still work required both at the production of material level in terms of how you can minimize and offset carbon at that scale, but also it's a lifetime issue. Embodied carbon upfront is an issue, but embodied carbon during the life of the building is also needs to be taken account of, so that whole of life embodied carbon, and not just the front end, which is the big number, but still is accounted for in the carbon accounting equations. So carbon reduction strategies in buildings, we are familiar with strategies to achieve net zero. Emissions occur at space heating, space cooling, hot water, lighting, electrical appliances, etc. We know materials manufacturing, transportation, construction, maintenance, demolition, all these are what the elements are that cause the emissions to go up at building scale. And then reduction opportunity to go even beyond the zero mark through efficiency and good design, on-site generation, off-site generation, and also factors like dematerialization, low carbon design, high recycled content, low carbon supply chain, and carbon offsets, etc. So you can see we can actually, by better understanding the emitted side of the equation, look at how maximizing on the opportunity for the reduction side of the equation. These can be looked at from both the top down and the bottom up levers point of view. Top down, when you start looking at how the grid itself is greening. Over the last 10 years, the grid in Australia has more than 20% more green electricity, and by 2030 the predictions are it will exceed 50%. And as a result of that greening of the grid, you can attribute those using and we have used in our guidelines the adapted Paris proof method to attribute it to building sector, and we find that in itself has a building sector target which can be reduced significantly over time. But in the bottom up, which is what we can do ourselves at on-site in terms of driving or improving the building or building stock as a whole, and data from the old CRC, ASBAC, neighbors and others show significant opportunity of improving the energy use intensity, but at the same time achieving best performance that goes beyond the current best performance into how much better we can be. When we look at carbon accounting itself in terms of national greenhouse accounting methods, the other thing to be aware of is this whole time of day issue. When you look at building consumption, which is the blue line that you can see, that's the consumption side. But when you look at the carbon intensity that we get from a grid level and from building on-site generation as well, you see that during the daytime, after 9 o'clock and up to about 6 o'clock, potentially in summer, that the carbon intensity is much lower because of the relative green electrons in the mix. So it is simply not accurate to report emission at the building or portfolio level by multiplying each unit of electricity used by an emissions intensity factor that doesn't account for when and how it was generated. When you get to that level of granularity, you might be finding that if you are deploying all the efficiency measures, generation measures, getting offset from outside the site and so forth, that you might be doing better than you might think if you look at the carbon intensity of electricity in the mix. So it's something just to think about. When you look at then targets and pathways for commercial buildings, in this case, we know that there are current average performance numbers available. So when you can easily find and the guideline that we have done. And by the way, when I introduced in the beginning that we have been working in this area for the last 30 years and seen the evolution of the discussions, the most recent of these is a book and a guideline we have done for Australia, which is looking at race to net zero and looking at target performance, which can be even better than what best performance numbers are like and the current average performance numbers that are floating around. So it would be much better to actually try and achieve target performance numbers, and which is even better than the best performance numbers for the consumption side. And then you start looking at what you can actually do through good design or refurbishment in efficiency, HVAC, lighting, equipment, shading and facades and fabric, etc. You can bring it down significantly. And then energy generation on site. You may find that photovoltaics and on-site generation is gradually becoming one of the cheapest of the options to generate electricity. And together, depending on time of day usage, the role of energy storage within that at building scale, we know that it plays a major role at the grid scale, but at the building scale. And if you come up with a deficit after all of that, you can buy offsite. You can actually get electricity accredited once from offsite. So you can deliver net zero today through a combination of efficiency on-site and off-site. That is possible. It's a matter of the appetite of the client and the motivation of the designers to drive that process towards net zero. And there are many examples today that are achieving that sort of goal. In the residential area, again, the same factor applies in terms of current average best performance and targeted best performance. You can bring it down so that the gradient of that line is much lower, and you can still make improvements in heating, cooling, water, appliances, glazings, and shading, and the good design measures that we have now all come to know. Together, coupled with on-site generation and off-site, we can go to net zero today. And I would say in most cases cost effectively, given the price of electricity at the moment, the uncertainties of demand supply matching at the moment that's happening. And you can be sure that you are all electric and not dependent on gas pricing fluctuations, for example, and you can achieve all these today. It requires a commitment both on the client side as well as on the designer side. So embodied carbon in that case, we have looked at numbers and find between 2021 to 2030, a lot can be done. There's existing buildings and there are new buildings. A lot more can be done with new buildings than existing buildings. But in either case, using efficiency improvements, on-site generation and offsets, you can drive. You need to have all the levers at play, and things like building codes need to kick in and set not to exceed targets. And these are based on a reduction over time, so that we think it can be changing in 2021 40% to 2010 and going towards offset to deliver on these. We have looked at in the guideline numbers around 2021, 2025, 2030 and 2040 for different building types, and what may those not to exceed numbers look like, so that we can overall achieve a net zero pathway for whole of building and whole of life. So the race is on in terms of trying for all building types, for all carbon emission categories, for all climate zones in Australia, to navigate from setting benchmarks and targets and pathways to moving towards sorting out the levers like standards and building codes that actually help you navigate towards net zero carbon. And then having methods of measurement so that they are consistent in terms of how we drive towards net zero, so that by 2030, we believe, according to our guide, that all new buildings and major retrofits can achieve cost-effective net zero operational. And to a large extent, a large part of the embodied as well by then. But the embodied in many cases, because of existing building stocks, may overrun to 2035, and in the worst case scenario to 2040. And so the race is on. We want to be able to, in buildings area, do it well before 2050 and deliver on net zero buildings. If using our guideline and pathway setting, you could do these guidelines for any country. So I know there are people from many different countries online today, and all you need is your localized data, localized benchmarks, localized goals in terms of targets, and put it in the context of local standards and levers and policies, and develop a pathway to net zero within the time that we think is best from a global sort of carbon perspective, which is 2030 as much as possible, and before 2040 for sure. So these are opportunities, and we're happy to talk and guide other countries in trying to achieve that. I thought to cover a number of other factors at the same time as well. When you look at energy rating tools that we are doing, simulation tools in particular, there are historical climate data files that are being used, and we know we talk about climate shifting. The climate data files needs to be changing very quickly at the same time. When you're looking at, say, in this case for Sydney, Eastern Sydney, the warm period and the cool period that used to be at play in the data is evolving. There are two major shifts occurring. One of them is the expanding of the warmer period, so much longer warmer periods, and the extreme events. For how many days at a time we will expect to be very high peak conditions. So when you look at 40 degrees C, how many days they were exceeded in Western Sydney some years ago, the data files from 2010 or so would have that. But now the number of days in the summer period when these extremes occur, recurring days of beyond 40 degrees C is much higher. And the trend will continue to a point where the summer, the warm period, which means cooling required, is going to become much longer. So it is very important, because when we build it today, according to these projections, the climate will clearly change within the period that we are building these buildings for. So we need to be looking at this as a factor quite significantly as soon as possible. The other thing I wanted to just add here, when you look at behavior change, comfort, well-being, the need for data, the need for knowledge, so that you can act appropriately is very important. You need guidance at the house and as a collection of houses within districts, and governments need to know for their policy purpose much more at a daily basis, peak day basis, but also on an annual basis. So over a 24-hour cycle, for example, how things happen in a building and a collection of buildings and different building types. What we did in the CRC was to develop a tool that allows you to monitor and display real-time energy and emission to the households for behavior change purpose. It won a Committee for Sydney award in 2019. And this tool has gone past the prototype development and is now increasingly going to be made available after a few more developments that are taking place at the moment. But it allows you to look at not only temperature, which is linked with comfort, well-being in different parts of the house, for example, the energy and the cost factors. What is it costing you to heat, cool, or run the building over a certain period, it'd be a day or a month, or also looking at emissions in that sense. It can look at the role of solar energy generation on site, to how much contribution that is making in terms of offsetting. And then it can look at also how much more is required before you go to net zero, and how much more is required before you start paying the embedded carbon debt, for example. So it's a tool that we think will be very, very important in the future. It talks not only about energy numbers and carbon numbers, but also can give you over a year your performance profile for different years. And in breakdown terms, looking at air conditioning, lights, oven, power, solar exported, solar generated, all these factors, depending on your tariff arrangements, and show you all these in detail. It also looks at your basic score, for example, and looking at actual performance in relation to that. It can show you how your house compares to what was projected, but also how it compares to the stock of houses who may be connected, and data is available over a period of time, so that it does your average comparisons with other houses of the same same time, same type, for example. So it's going to be quite a powerful tool, we believe, and once developed, it can be not only very useful at a household occupant level, but also at the government and policy level. There are few other things happening globally, as I mentioned earlier. The emergence of building codes globally. You can see mandatory codes in so many countries already, if you look at the index here. But it is not always clear what is mandatory, whether it's net zero. Is there a trajectory to net zero that's mandatory, or is it just some elements of energy use? But there is significant coloring here taking place where it is at least some level of mandatory building codes are in place. There are others where it's voluntary and in development, and we know where the focus should be, especially for UN and other agencies who can actually know where to focus on to make those improvements that are required. A lot is happening globally in many circles. The Global Alliance for Building and Construction, you just have to go on their website to find out their reports, but they have got a short-term, medium-term, and long-term view of how the navigation towards net zero would occur. Global Alliance for 2030, which is short-term, net zero operational ready for all new buildings, they are saying, which is very similar to what we have said in our Australian guideline that we have produced. Net zero embodied carbon by 2040 for new building in some countries under Global Alliance. And by 2050, clearly trying to reach all buildings. World Green Building Council, one of the major organizations globally, 40% reduction in embodied carbon for new building structures, net zero operational carbon for all new buildings, and they pushing towards net zero operational carbon for all buildings, including existing buildings, by 2050. RIBA, the Royal Institute of British Architects, has its own numbers in terms of 40% reduction in embodied, 58% operational energy reduction in new build offices, and 71% reduction in domestic buildings. And through these, they hope to drive much more rapid change. There are others like LETI, London Energy Transformation Initiative, which asks for 65% reduction in embodied carbon. You can see that embodied carbon is now emerging more seriously in all of these, and including Australian ones, which shows the importance that I raised earlier. The American Institute of Architects, 100% carbon neutral, using no fossil fuel greenhouse gas emitting energy to operate for all new buildings. 45% reduction by 2025 and 65% by 2030. So they have some serious targets in place. Architecture 2030, if you want to look them up, they have documentation that you can follow up in terms of the details of some of these numbers. International Energy Agency, all new buildings are zero carbon ready by 2030. 20% of existing buildings retrofitted to be zero carbon ready, and 40% reduction per square meter of new floor area by 2030. And then changing to 50% of existing buildings retrofitted to zero carbon by 2040, and by 2050, more than 85% of buildings are zero carbon ready. And 30% reduction in the use of energy intensive materials per unit floor area. So they have their own numbers, and you can look at how everyone is beginning to navigate that way. The Danish government has its own targets, phase targets from 2023, reaching 90% of new construction performing better climatically than currently by 2029. So it's within the 2030 sort of timeline that we are looking at. Australian governments, this is from before the election. All states and territories have their goals and targets. The federal one, you all know, those within Australia know that the 26 to 28% has now gone to 43%. And there is a significant push in terms of driving towards net zero by 2030 by the new government here at the moment. So there's a lot happening. What we need beyond these targets are actual initiatives and measures that will drive these in a meaningful way. Other Australian initiatives are at work. The GBCA in Australia and the neighbors, they are doing a lot of good work. Their tools are adapting and trying to look at both operational, they have roadmaps and embodied carbon and so forth. National Construction Code, which is the other big lever that we need to make sure that we engage. Council of Australian Governments, Australian Sustainable Built Environment Council, which is the peak of peak industry bodies. These are all engaging in a way, and it's required to have all these sides working together to drive towards net zero so that we can get a consensus and overcome barriers together towards driving to net zero. Otherwise, it is always an argument for why we can't do it, as opposed to how well we can do it while creating jobs and future opportunities for the economy and for communities in Australia. Other initiatives at the level of City of Sydney, City of Melbourne, and a number of other cities already engaging in these arena. Sustainability Victoria Beyond Zero Emissions has launched its zero emissions buildings plan, and Mattheos and Basics are trying to look at introducing even material embodied carbon target for houses at some point in time. The CSIRO, of course, whole of house performance rating tools are being looked at, which will drive things further. Neighbours has also started working towards introducing material embodied carbon in coming years in ways they are beginning to work out how best to do that. So these, if all these initiatives have matured by 2025, according to our guidelines that we have developed, then it makes it so much easier that by 2030, we can start delivering on some serious carbon reductions in Australian building stock by 2030 and help deliver on the government's 2030 plans for 43% reductions and better from the building sector contributions point of view. And then it becomes easier in the future years. We, as the New South Wales government has clearly taken leaderships in many ways in trying to make sure through its new 2030 decarbonisation plan that they are looking at making sure that we can capture the economic advantage in going towards net zero carbon, and they have established decarbonisation, innovation hubs, etc., to help drive that change and capture the benefits. That's where I think the clever money is on these days, to not only think in terms of emissions reduction as a problem we need to face, but as an opportunity where we can, through these, build economic capability and opportunity that would otherwise may not be captured for Australia in this case, but it applies to other countries at the same time. So thank you very much. I had promised Len that I would finish in 45 minutes, and I think I am just there now. And I will try and address a number of questions coming through. So Len, do you want me to continue with some of these questions?
Sure. Dale, thank you so much for your wonderful talk. We have received some questions during the registration process, and also a few comments coming through the chat. So over to you.
Okay, thank you. So where there are more questions, I will try and get back on the Zoom system by answering those. So given the time that we have, we probably can answer some of those. I think, let me start. So Becky Sharp asking, do you think there are any adaptation mitigation measures that are particularly suited to buildings being occupied by low income or vulnerable cohorts, that is social housing? I think that is very, very important question. Clearly, in the minds of people, we have this idea that when you try and build these super efficient net zero houses, that the costs go up in construction. In if actual facts, I think you can build very efficient net zero type houses without increasing the cost by being clever about how you build them. As I mentioned, in terms of good design, passive design, as well as active efficiency improvements, on-site generation, and offsets. So if the electricity cost goes up as it is going in Australia at the moment, clearly some sectors of the community are paying inequitably high costs, and the social housing people are clearly part of that low income group that are doing that, and the whole issue of fuel poverty is linked to that. A lot of the housing here in Australia linked to the low income groups are built by governments, and with most consideration being given to the building side as opposed to operating side. Operating is where the occupants start paying the electricity bill. So I think there is significant opportunity for making these through new build, or as I have said, or through refurbishment, much more efficient, so that in itself is trying to bring the consumption down. How much best performance, in other words. That's clearly one part of the equation. The other is renewable energy. I mean, there have been government incentives for using on-site generation for some time. One of the best options, in my view, is that all these social housing projects come with on-site generation of this size that can actually offset most of the electricity bills. To do that, we clearly have to make sure that these are all electric houses, because the big variable in the room is gas, and the gas prices, if they shoot up, then by solving electricity price on the one hand, you having gas price problems, and they still cannot afford to use them. The idea is to start a progression towards all electric homes as much as possible, then have approaches where you can have the mix of efficiency and the reduction through on-site generation. You can actually have, for these social housing, net zero, no houses with no bill, that can make life much easier for particularly these groups, but it is available to all groups to be able to get these benefits. So that's my suggestion in terms of requirements, that they should all look at having on-site generation to offset the electricity use. I have another question here. What will be the key responsibility or challenge for design engineers in the race to net zero carbon buildings? These are key players, both architects and design engineers. Architects, through good design, simply choices of facades, choice of materials, how you insulate, being aware of where the location and climates are, so that you give the best opportunity for lowest design. And when the project goes towards looking at systems design through design engineers, that we absolutely explore the most efficient And I think that at the time of hiring of engineers and architects and other professionals involved, there should be a good conversation with the clients who want to see change, clients who want to aim for the best performance. And this is very evident in a lot of the large client base now for buildings, that they are trying to go net zero by 2025 as a portfolio, and that sort of time scale. And they should have good discussions in terms of discussing the client designer common understanding of by what date would you like to achieve net zero. The ways in which it can be done is all available to good design engineers and architects now. It's a matter of setting a timeline and the appetite for the client to see when they want to go to net zero. Engineers should be able to deliver that using the mechanisms we talked about, from efficiency on-site and off-site. I think it's up to the engineers and architects to drive that change process towards net zero. All the tools are available. All the technologies are there to now try and drive us towards that. Even materials emerging from an embedded carbon point of view, how do you account for all of those so that you offset any upfront carbon you have in terms of credits, so that you can deliver by 2030. And all engineers, I think, should be responsible to look at 2030 as a good target date. The next question, I guess, is what are your thoughts on green roofs, pros and cons? So this is worth a whole book or three that we can do on green roofs. I think on balance, when you look at different locations and different building typologies, some are more amenable to much more sophisticated green roofs, including not only the green roofs with vegetation and all of that, but also using photovoltaics in combination with those, and how much of the roof you dedicate to green roof and how much to photovoltaics. Those are the types of questions we might have. But not only green roofs, cool roofs. A recent bit of work by my colleague, Professor Santamouris, which has looked at cool roofs and the impact it might have both on network level system demand, but and also in terms of comfort and well-being inside the building, but also in terms of urban microclimate impacts and energy and carbon. There are very positive impacts in terms of cool roofs as well. So do look up a report that might be at the High Performance Architecture website, but I'm not promising you that. If you just email Lan and she can find out more detail of where it is at the moment. But Matt Santamouris is the lead author of that. Next question, shall we put carbon budget in place for buildings in Australia? Yes, we have tried to do that in our guideline. We have looked at the best of best performance and looked at what would be the benchmarks today from existing benchmarks to best performance benchmarks to target performance benchmarks, and there is data increasingly being made available to do this, and we can from those set carbon budget levels. Of course, when you talk about setting budget levels, you are setting it on the basis of a uniformity in thinking in the marketplace. There would be issues and objections around that as people get that concept around their head, because we do know that there are many organizations who have not uptaken the whole issue of net zero carbon, for example, on the basis that it might be too expensive for some, but I think it might actually be the best for the lowest income group if things like photovoltaic offsets give you net zero electricity bill over a period, and you don't have to pay because it's all being offset. So these things are acting in the benefit of the low income end as opposed to being a cost to them. I think we need our community to be thinking in a much more today terms, in terms of photovoltaics and the cost and benefits and all of those things as we go into the future. How do you think we should approach the dilemma of pursuing improved building fabric energy efficiency, but where extra materials and embodied carbon are required to achieve this, knowing that the building will operate with an increasingly renewable energy supplied grid over its lifetime? So I guess this might be the last question given where we are in terms of time. But when you're looking at the lifetime of buildings and what we are doing today that will last 50 years and so forth, we need to be very careful. We do not want perfection, in other words, to be the enemy of the good. In many cases, people start thinking about a perfect solution, but many don't get it around their head today, simply because they might say, oh, it's too expensive, or it can't be done, or there's not enough technology. What we want in terms of 2030 being net zero, but the transition from now till then. So the earlier question, how should engineers, design engineers and architects behave in all of this? I think they should look at this transitional pathway where we are today, how we can get an idea of where we want to be in 2030, which is close to net zero as possible, and then map out how that transition will take place. Transitions need to be navigated with care, and the fact that changes will occur, new technologies and materials will evolve, and that we will land in a place of perfection by a date such as 2030 for net zero. But let's understand the transition and understand that we will need to build progressively. So weather data I mentioned, we have to start changing now because the buildings will be there for 50 years. And as a result, we will have locked in materials and facade and so forth that might act against you in delivering. We can't have all the new materials are not there today. They will evolve over time. We will have materials that are with integrated photovoltaics, for example, thin film and printed solar and technologies like this will link with material types to deliver the best outcome into the future. So we need to allow for innovation. Innovation will keep coming, that they will keep changing new materials, changing, improving embodied carbon and so forth. But at the same time, we have various tools, as I mentioned, on-site generation, which you can play with. In the future, maybe on-site will be not only on the roof, but on facade, material integrated solar, and then you always have the offset from outside of your site to bring more renewables. As I said, the grid is getting more and more green electricity, and in 30, 40 years time, we hope it will be largely green electrons in the system. My own university, you probably many of you know, UNSW did a level of efficiency improvements. Then they looked at roof spaces and how much solar they can put on roofs here, and then looked at a farm, a solar farm at the border of Victoria and New South Wales, from where we get enough electrons to 100% offset our electricity demand. So it is possible to get from offsite sources and deliver net zero from that perspective. more and more advances would occur, and we hope that for example, my most recent job now, as Len mentioned briefly, is on 2 projects. One is the Australian Trailblazer for recycling and clean energy, and together with the New South Wales government's Decarbonisation Innovation Hub, both having the same opportunity target: decarbonize as rapidly and as much as you can while capturing the economic impact for Australia and New South Wales, the 2 different projects, and building capacity to allow us to navigate along that pathway effectively. So given all of that, I think we can deliver on these in time. So that's 2 o'clock, according to my clock is asking me to stop. So I better pass it to Len. Thank you.
So thanks, Dale, so much for your wonderful talk. For remaining questions, we will send Professor Dale's answers to you by email. Thank you very much for joining us today. The 3rd High Performance Architecture webinar will be in July. Myself and Renae Walton from the city of Port Phillip will introduce an award-winning project, Cooling South Melbourne, a case study in the next webinar. Registration link is now available in chat. So thank you so much, and we look forward to seeing you in July. Bye-bye.